Quick revision video on group 2. So we'll start with some general information. First, all group 2 metals have the outer shell S2 electron configuration. They lose these outer 2 electrons and form 2+ ions when they react. So because they lose electrons, they are classed as reducing agents, electron donors. And they only lose 2 electrons because the third ionization energy is too large. Because to get the third electron out, you're breaking into a new shell. So the reactivity of group 2 metals now. So the trend is they get more reactive as you go down the group because of the atomic radius increases. So the outer electrons, those 2 outer electrons that they are losing, are getting further from the nucleus. The amount of shells between the nucleus and the outer electrons increases, so shielding increases. So because of that, the attraction between the nucleus and the outer electrons decreases. And as a result of all of that, the electrons are therefore lost more easily. So their first and second ionization energies decrease as you go down the group, but remember the third ionization energy is very large. Reactions of the elements now. So when they react with oxygen, they form oxides. So there's an example there using magnesium. When they react with water, they form hydroxides and hydrogen. So there's an example with calcium. And when they react with dilute acids, they form a salt and hydrogen. So I've used barium and hydrochloric acid to illustrate that one. Reactions of the compounds now. So it's just one reaction here. It's the action of water on the oxides. So I'm using beryllium oxide to illustrate this one. So we get beryllium hydroxide. The pH of these hydroxides is greater than 7 because they are alkaline. And as you go down group 2, the hydroxides get more soluble, and so the hydroxides will become more alkaline because you're going to have a higher concentration of hydroxide ions. So we'll finish with some uses of group 2 compounds. So calcium hydroxide is used to neutralize acidic soils. So there's an equation that illustrates that. Magnesium hydroxide is used as what's called an antacid. So that's found in indigestion remedies. So it's going to neutralize excess stomach acid. So there's the equation that goes with that. And the final use I've got is calcium carbonate, again being used as an antacid. So it's reacting with hydrochloric acid in the stomach. And that's the equation there.